All right, welcome to our channel where we are presenting lessons in mathematics. So in this lesson, our interest really is to understand tangent and the normal lines. We want to understand what these lines are. Right, now, we are saying these lines are defined on a curve. Okay, they are defined on a curve or by a curve. So if you have a curve f of x, as we are able to see, then you draw a line in such a way that it meets the curve at only one point. The line that you have drawn will be referred to as a tangent line. So in this case, this line that we are able to see here is a tangent line. Okay, is a tangent line. Okay. So now, if you draw another line in such a manner that that line that you have drawn and the tangent line are meeting at 90 degrees, or they are perpendicular to each other, okay? Then this line that you have drawn, that is perpendicular to the tangent, the line is referred to as a normal line. So we have got two lines, the normal line and the tangent line, okay? Two lines, normal line and the tangent line. Now, we are saying the normal line and the tangent line are perpendicular. Okay, now, going by coded geometry, you agree with me that by perpendicular we mean that the two lines have a gradient of -1 if at all we multiply their gradient. Meaning that if the gradient of the tangent is m1, okay, and the tangent of the normal is m2, what does it mean? What it means that when you multiply a1 or m1 by m2, the answer must be -1. Alright? The answer must be -1. Alternatively, we can say if the gradient of the tangent is dy dx, alright? It's dy dx. What does it mean? It simply means that when you say dy dx multiplied by m2, the answer should be what? -1. Now, dividing both sides of the equation by dy dx, what do we get? Dy dx. Here, dy dx, okay, dx, what do we get? So dy and dx will cancel. This means that we have m2, that is the -1 over dy dx, meaning that this is the gradient of the what? Normal. Alright, gradient of the normal line. I hope that is clear. So we're saying m1 by m2 is -1. Supposing that the gradient of m1 is dy dx, what does it mean? It means dy dx by m2, the answer is -1. Dividing both sides of the equation by dy dx, what do we get? So here divide by dy dx, there dy dx. So dy dx here will cancel, remain with m2, which is this one. So here we have -1 over dy dx. So this becomes the gradient of the normal. The gradient of the normal. Okay, the gradient of the normal. Okay, so this is very important. So now, our interest now is to look at how can we get this gradient of the normal and the gradient of the tangent. How do you get the gradient of the normal as well as the gradient of the tangent line? Okay. Okay, so let's see how we can get the gradient of the normal and the tangent. The Gradient of the normal and the tangent. Okay, so let's look at the example that we have. We are saying find the gradient of the tangent and the normal to the curve. Y is equal to x squared plus 2x plus 2 at this point. Alright? So take note, by this point we mean this is x and this is the y. Okay, so that is x is equal to 2 and y is equal to 10 at that point. Okay, so how do we find the gradient of the norm and the tangent? Now, the gradient of the tangent, is dy dx. That's what we've said. Okay, so by gradient of the tangent, we want you to find the derivative of this function at 2, 10. Alright? So what we are going to do is to differentiate this function and find the value at that point. So we are going to say dy dx is equal to, so the power law demands that you multiply the power by the coefficient. So we'll have 2, because the coefficient here is a 1. So 2 by 1 is a 2. X, 2 minus 1. Alright? Plus, here the power is a what? It's a 1. 1 by 2, you get 2. 2x, alright? It's like 1 minus 1. 1 minus 1 is a 0. So we have 2x plus 2x to the power 0, right? Now, so 2x to the power 0 implies 2 by x to the power 0. And x to the power 0 is a 1. Meaning that here we say 2 by 1. And the answer is what? 2. Okay, so meaning that the whole lot of this one should be replaced by 2. So here we have 2 as our gradient function. But now we want to find dy dx at x is equal to 2. This implies that dy dx is equal to 2, open bracket. Here where there's x, we put 2. Right? So we have got 2 close plus what? 2. So 2 by 2 is a 4. 4 plus 2, you get a 6. So the gradient of the tangent of this curve is 6. Are we together? Okay, so we can get the gradient of the normal. We get the gradient of the normal. Gradient of the normal. Now, like I explained earlier on, we are saying gradient of the tangent, which is m1, by the gradient of the normal, which is m2, produce a negative 1 when they are multiplied. So the product of their gradients is a negative 1. Alright? But we have said the gradient of the tangent, we got the gradient dy dx was equal to 6. Meaning that here we'll put our 6 and say by m2. What do we get? We get negative 1. So how do we get m2? We divide both sides of the equation by 6 because we are multiplying them. So here we divide by 6 and here we divide by what? 6. Okay? 6 and 6 will divide. So here 1, 1. Okay? So here you remain with m2. So m2 is equal to negative 1 over 6. Therefore, gradient of the normal is 6. It means this question has been answered. Alright? Sometimes, looking at this point that we have been given, at times you can only be given a point, say at x is equal to 2. So the approach will be the same. Okay? I hope this presentation has been very helpful. If you like our presentation, if you like the way we are presenting these lessons, please I would encourage you to subscribe to our channel so that you're able to access more of these videos. Thank you so much.